Hey everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to continue in chapter number 7. In the last lesson, I talked to you about the fact that we're going to be kind of transitioning away from algebra a little bit, and this is the lesson that it really starts. If you will look at your book, we are on page 332, 332, and we are on 7.2. Exponential functions, 7.2 exponential functions. Well, as you're looking there, you can kind of look down at the screen, and I have something written down, and it's also in your book. There's really two types of functions, if you will. There's more than two, but that at this point we've covered. We've covered algebraic functions. That's what we've been covering. Now we're going to get into what's called transcendental functions. They go beyond or they transcend regular algebraic expressions and equations. What does that mean? It means that they're a little bit deeper. There's a little bit more to them. And they don't always follow the exact same rules that the algebraic functions follow. Okay, so there's two different ones. And again, we're on page 332. There's two different types of transcendental functions. The first one is called exponential functions, and you'll see that right there on your screen. Number one, exponential functions. And then number two, they are logarithmic functions. We are going to focus, at least in today's class, on number one, exponential functions. However, in the following lessons, we're going to be talking more about logarithmic functions as well. The way that this chapter works is each one of these lessons is pretty long. So there's only 6 lessons, but I'm basically going to take each one of those lessons and I am going to divide them up into two lessons each. So there's going to be an A lesson and a B lesson to each one. So at the first part of this lesson, we're just going to kind of introduce exponential functions. I'm going to show you some things on your calculator that maybe you've never seen before, and just talk about how those exponential functions are going to work. All right, so you can, again, look down there on the bottom of page 332, and where it talks about exponential functions, you'll see kind of an example of one, and I want to talk about that. Exponential functions have constant bases with variable exponents. Okay, so what does that mean? Well, until this point, we haven't really dealt with variables in the exponent. We've dealt with x cubed, x squared, x to the fourth. We haven't dealt with 3 to the x. Okay, so look at these examples that I wrote down here. All right, example number 1 is an algebraic function. This is what we've been dealing with. X to the third. That's normal. That's something that we've been seeing a lot of. In the second example right here, that is an exponential function. Now look at what we're dealing with. We're dealing with 3 to the x. 3 to the x. In other words, what we're going to be doing with these is we're going to be finding the exponent. Instead of them giving us the exponent, we have to now find the exponent. And if you think that that might be somewhat complicated, you're right. And so we're going to have to pay attention here. We're going to have to try to figure out what's going on and how all of this stuff works together. All right. There are 2 restrictions. If you'll turn the page over to 333, that's 3 threes, 333. And so if you look at page 333, you know what? 3 is a great number. I love the number 3. 3 is one of my favorite numbers. It's a biblical number. In the Bible, there were the God is three people: God the Father, God the Son, God the Holy Spirit. Jesus lived to be 33 years old. There was 3 close disciples to Jesus. I know there was 12 total, but there was 3 that were very close to him: Peter, James, and John. Just lots of 3s all the way through the Bible. He was in the ground for 3 days after he died. He died with 3 people total there on the cross of Calvary. Lots of 3s in the Bible. Something interesting to study sometime is the number of 3s that appear throughout the Bible. But anyways, we're on page 333. So 2 restrictions. And that was free, by the way. Yeah, that was just, you can look into that on your own and enjoy that. It's a great study. Two restrictions on these equations, on these exponential equations. Number one, restriction number one, the base must be greater than 0. In other words, what am I saying by that? 3 to the x, okay? This is the base right here. That base must be greater than 0. What do I mean by that? Well, it can't be negative. I can't have negative 3 to the x. We're not going to be dealing with things that are negative. Well, I say that, and then I'm kind of telling you a little bit of a lie, because in the following lessons, we're going to learn how to deal with this. We have to deal with it. Basically, that gives us an invalid imaginary response, and so we have to do something with that negative sign. But for right now, for this lesson, you can't have negatives. They're not going to work out. It's going to give you an imaginary response. But we'll cover that more in the next little bit. Let me show you one thing. Timeout. Okay, let me show you this one thing real quick because I just thought of it. So let me show it to you. What does it mean when it's a negative? Watch what this means. If I have a negative, let's say 2 to the x, let's just put something in for the x, and let's put in especially and remember what I said, the base must be greater than 0, but let's say that this is a fractional exponent. Well, what does that mean? Well, that means that it is the square root of negative 2. And notice that imaginary would have to come out. So imaginary square root of 2 is what you would get. So whenever you have this negative, it doesn't always, but it can yield an imaginary number. And so you can't have, right now we're only going to be dealing with bases that are greater than 0. So no negative numbers. All right, the next one is the base cannot equal 1. Why not? Well, check this out. So if I have 1 as my base and x is my exponent, x can be whatever in the world I want it to be. What if x is 5? So I have 1 to the 5th. Well, what is 1 to the 5th? 1. 1 times 1 times 1 times 1. 1. What is 1 to the 8th? 1. In other words, if 1 is the base, then your answer is always going to yield 1. So it doesn't really matter what your exponent is. So those are kind of two restrictions that we're going to put on this. That way you know that these are always going to give you a valid answer. Again, at least in this lesson. As we continue, sometimes they might break those rules right there and give you things that you have to solve a little bit further. But for right now, those are the two restrictions we're going to put on these. So must be greater than 0, no negative numbers, and the base cannot equal 1. All right, let's work one of these out. Let's see what we got here. So let's take a look at this. Let's evaluate this. Let's figure this out for different values. So let's evaluate this. Let's say x equals, and we're not finding x. I'm telling you what x is, and then we're going to figure it out from there. So x is, let's make x negative 2. Okay, well, what does that mean? So, well, let's plug it in. What do we always do in algebra when we have something? We plug it in. Okay, and so we're going to do the same thing. Just because we've switched over to exponential doesn't mean that that's changed. Some other things have changed, but that's still the same. Whenever we give the x value, we just plug it in for x. So what is that? 2 to the negative 2. What does that mean? Do you remember how to solve that? Well, what we do is we flip that, we invert that, and so it's 1 over 2 squared. That's how we eliminate that negative sign. We eliminate the negative sign by inverting the fraction. And then we have to multiply that out. So what is 2 squared? It's 4. So 2 to the negative 2 equals 1/4. So when x equals negative 2, this exponential equation is going to yield 1/4. Let's try it again. Let's pick a new value for 2, or for x. Let's say now x equals negative 1. And so again, we're going to substitute that in. So 2 to the negative 1. Again, we flip it again. because we need to make that negative a positive. And so we flip that over and we get 1 over 2 to the 1. What is 2 to the 1? It's just 2, so that equals 1/2. Let's evaluate it for x equaling 0. You said, Mr. Steve, I thought you said that the base couldn't equal 0. The base doesn't equal 0. This is the base. Okay, you're confused right now because you're used to the base being the x, but the base is the 2 here. Don't forget, this x is the exponent and the 2 is the base, so we got to make sure that we're on the same page right there. So substitute that in and we get 2 to the 0. Well, immediately you should remember the rules for 0 exponents. Anytime you get a 0 exponent, the answer is always 1. You don't even have to try to figure anything out. 2 to the 0 equals 1. Anything to the 0 power always equals 1. Well, technically 0 to the 0 power doesn't really equal 1, but that's another discussion. Okay, I'm not going to have that discussion with you right now. All right, so let's say 2 equals 1, or x equals 1. So now this time is 2 to the 1. Well, that just equals 2. Okay, do you see how every time I change the value, it's changing the output? And then let's do this one finally, and now it's just x squared, or 2 squared, equals 4. Okay, so every time I change the x value, what changes? Well, the exponential equation changes and the output changes. The value of the answer is going to change. All right, I want to talk to you just a little bit about calculator use. Now, there are literally thousands, probably, I don't know, hundreds, we'll say literally hundreds. I know that there's hundreds of calculators that you can use. Now, a little baby rinky-dink tiny basic calculator is not going to work for this. You need to get a scientific type calculator, a calculator that is built for these types of calculations. So if you don't have one, you need to get one. That is extremely important. Most of your cell phones, okay, most of your cell phones have one. And so you can use that if you want to. I don't love my calculator on my cell phone. I'm sure that there's some apps that I could put on there that'd be a better calculator, but I don't love it. So I suggest you getting your own calculator. For this class, I'm going to use the calculator that is standard on my computer. All right, so here's my calculator. I'm going to use the one so that you can see it on the screen. You can kind of see it as I go over them. You can kind of see the button light up a little bit. So I've also got one that I can write on. I can't write on this right now because if I try to write on it, it's going to push the buttons. So I've got one that's kind of in a picture that I can write on, and I'm going to help you see the different functions. Now, what I want to say about this is that my calculator is going to look very different from your calculator. All of these calculators, hundreds of calculators that are out there, are all going to have different styles of pushing buttons. So maybe your calculator, you have to push the button first, and then the number, and then on somebody else's, they have to push the number first, then the button that goes along with that, what they want to do. Some of you have to use parentheses, some of you don't. The buttons all look different. And so I can't really tell you. You're going to have to consult your own owner's manual. You can look them up online if you need to, but everybody should have their own calculator. If you're using a cell phone, if you're using a real calculator, if you're using the computer calculator, whatever you're using, please have a scientific calculator for really the rest of the book, okay? Very important for the rest of these chapters that are going to be in the second half of the book. All right, so as we go through this, I'm going to explain some things on my calculator, but you need to try it on your calculator so you see which buttons work and in the order that they're going to work in. You should get it to give you the same value that I'm getting, but it's going to look a little different in the way that you do it. So if you look on page 333, the bottom of the page, here's what I want to show you. I want to show you this calculator, and this is going to allow me to write on it. I want to show you this button right here on this is what mine looks like, okay? This is the one right here that I'm looking at, okay? Circle it in red here. X to the Y, X to the Y. Now yours might look something different. Yours might say something like n to the x or y to the x or even a number like 2 to the x or something like that. And what that is that means that you are able to put in a sometimes it even has a little box on it, so it doesn't even have an X. It'll say like X to the box. And again, I can't help you with every single calculator because I don't know what every single calculator looks like. But this one that I'm looking at says X to the Y. All right, so let me show you this. Let me show you how this works. All right, so I'm going to come over here real quick, and I'll write this here so you can see it. And on example A on page 333, 7.2b at the bottom of the page, it tells you that your base is 2.1 to the x. The base is 2.1 to the x. And then it says in the next column, it says that the value of x equals 5.2. The value of x equals 5.2. Now this should give us a value. Now when we go back over here to our calculator and I put that in, I'm going to put in 2.1 and then I'm going to hit my x to the y, or maybe your calculator has the x to the box or whatever it says. I'm going to hit that button and it's going to, on mine you'll see up here in this upper corner, it's going to put like a little up caret. It's going to show you that it's going up. That means exponent to the 5.2, and then we need to put in 5.2. And then we're just going to hit equals, and it's going to equal 47.3740302053. Wow, look at all those numbers. What does that mean? It means that this gave us an irrational number, right? Well, the book says round each value to 3 decimal places. So we want to write on this, we want to say that it's about equal to. This sign that you're going to use kind of looks like bacon, all right? That's what I say. I say bacon is approximately. So put your bacon on there. And then so it's approximately 47.374. Let me pull the calculator back up. And you'll see 47.374. So we just round it off there at the third number. And so that would be our approximate answer. Okay? Again, you work with your own calculator. You figure out how each one is going to come out and what buttons you have to push in which order. All right. One more thing for this lesson. I want to talk to you about Euler. Leonhard Euler. He was a mathematician. He's German, I believe. And he was back in the early 1700s is when he was born. And Euler is the one that came up with, he called it, I don't know that he called it that, but people call it now Euler's number. Okay? It's known as the natural base. The natural base. Notice this right here, this little E. And it's an E in like italics. It's not a regular E, it's an italics E. If you'll go back to your calculator, look on your calculator, and you are going to see, actually let me pull this one up. You are going to see the Euler's E on your calculator somewhere. Now it might be in the second functions or it might be in the first functions, but it's going to be on your calculator somewhere. If you have a scientific calculator, it'll be on your calculator. It is a very important number, and so let's talk about it. Let's talk about why it's important. It is important because it's an irrational number like pi, and it equals 2.71828 approximately, so we put some bacon on there right there, all right, our kind of equal sign, swervy equal sign. And your calculator has a special key. It's used in many calculations. Now, scientific calculations, different types of calculations. It's an important number. So important that every calculator in the world, basically every scientific calculator, has an E. It has Euler's number. So it's very important. You don't need to know what it equals. Your calculator knows what it equals, okay? It'd be great if you memorize that. I think that'd be awesome, but you don't have to know that. I'm not going to require that. Notice that it says another common base is 10, and this is used in many electronics. Maybe you've heard of binary code. Okay, what's binary code? It's ones and zeros. So 10 is a very, very useful base in computer programming and other things because of its use of ones and zeros. Let's do one example with Euler's number. So if I say e to the x, and if I say x equals 5.2, what does that equal? Well, we bring out our calculator, clear this one out, and we're going to hit the E button because that's our base. Our base is E. So come over here, hit the E button. And it's going to, I don't know, again, different calculators are different. Mine brings up Euler's number, okay? And so then what I want to do is I want to go to my x to the y, or my x to the box. So it lets me put in whatever exponent I want. So I click that, and then I put in 5.2 for my exponent, okay? And now I'm just going to click equals, and that is going to equal about, or bacon, 181.272, and we'll again round it off to our three digits, our 3 decimal points right there. All right. So, and again, sometimes you might want to go more decimal points, but for this book, for what we're doing, 3 decimal points is plenty there. Okay. All right, lots of information there. Make sure you go back, rewind it, and watch it if you missed anything there. Hopefully you learned something today, and we'll see you later. Have a good one. Bye-bye.